Welcome, Algebros. This is the most important of the entire year, the most important lesson that you will see in its entirety. Here is the scenario. We are talking about quadratic polynomial functions, also known as parabolas. There are three distinct different forms that we can see it in: standard form, general form, and factored form. Okay? And we can even add in here right now that this guy is also known as zeros form as well. So there's alternate names, right? It could be called standard or vertex. It could be called factored or zeros form. Now, this layout, and we're going to fill in all of these boxes here with information, formulas, and everything. Because what's going to end up happening from here on in is that we may be dealing with quadratics in a problem, but not every problem is going to have all three forms. Sometimes there may be a standard form with a factored form. Sometimes it may be general with standard form. And you'll have to know which formulas to use in what case. So what this is showing you is if I was given a question in standard form and reading through the word problem, because these are all going to be big word problems, different scenarios, and I had to find the H value, well, how would that look if the question to me was presented in standard form versus how would that look for me to solve for that if it was in general form, and how would I do it if it comes to factored form? So essentially all I want to point out here, and I'm just going to put a little disclaimer here. Let's put a function. Let's stick f of x. F of x is 2x minus 2 squared, and then let's just say minus 4. Okay. Let's just use that as a placeholder, because if I'm looking for the h value of this guy, the actual value of it is opposite h. Meaning in the formula, it says x minus 2. So my actual value of x is positive 2. That's it. Do not overthink that one. But when I pull it out there, and here's the one thing that's going to be the struggle for today is when it's in the form of a rule, right, it looks backwards. And when it's outside of the form of a rule, when I have to use it for a formula or use its real value, we treat it differently. And just as an aside, if you're wondering like when I use the phrase the rule of a parabola, this is the rule of a parabola. This is the rule of a parabola, and that is the rule of a parabola. Before we go any further, let's just talk about how you'll notice when I put a value for A and a value for H and a value for K, if I have all three of those parameters, then I have the rule. Same thing with this guy here, A, B, C. If I have a number for A, B, C, I now have the rule. It just defines the rule, where it exists in space, where I can graph it, where I can plot it, right? If I'm missing any one of those things, I do not have my rule. And last but not least, if I have A, Z1, and Z2, right? Then that's essentially the parameters that give me the rule. And I'm going to use that specific word as well here, that a lot of this is talking about you've your whole career probably looked at any letters and you've identified them as what? Variables, right? You would say it's a variable. I'm going to tell you to now talk about AHK, ABC, and AZ1 and Z2 as parameters because they have more meaning, right? They have way more meaning than X and Y. X and Y are just variables, okay? And A, H, and K are parameters because they indicate everything I need to know about that rule, okay? So from here, let's continue on and identify what would K be in standard form. Don't overthink it. It is, you don't have to write this, but it is what it is, as in K would be equal to -4 in that example up there. That would be it. There'd be no thinking to it. So H, I take the opposite from the formula. K, because it's not in brackets, because the formula doesn't say minus it. It just is what it is. There's no overthinking it. And now we're going to modify this section here because there's really going to be two parts to this. Okay. So the top part is just going to be solving for zeros, which is also known as the x-intercepts. I should even put the x-intercepts, right? Multiple, plural. And that exists where y is equal to 0. And so there's two ways to solve for zeros and an x-intercept, okay? And those two ways are, number one, B and algebra or algeno. As in, you're just going to solve it using algebra. I'll give you examples of what this looks like on the next page. But for right now, B and algebra, so just solve it algebraically. The second option for this is if I'm solving for zeros, I just plug it into this formula here. H plus or minus square root of negative k over a. So I take my a, I take my h, I take my k, and then I plug it into that formula. It will spit it out. You will probably find you're more comfortable with one versus another form. Okay? I would stick to it. My suggestion in terms of what I think is easier is just be an algebra.
What if the k is already negative? Does
It would become positive, yeah. So, in fact, in this example here, you make a good point, right? If it wasn't, right? So if I had, I'm going to erase this here, but A was 2, H was 2, and K is negative 4. So that would be plugged in as 2 plus or minus square root of negative 4. So we could just say positive 4 divided by 2. And then I'd be able to kind of solve it from there. But yeah, you're just going to put the opposite of its real value, which is a weird thing to kind of make sense.
the opposite of what's given?
Well, not the opposite of what it's given in the rule form, because that one I don't have to take the opposite of it to get the real value. Yeah. So I just take it as it is.
Just take it out of the formula.
Yeah, exactly. So these two things here, though, they're not just used to find zeros. They're actually used. So in this block here, I'm going to say number one, I can use my algebra skills and that formula to find zeros. I can also use my algebra skills and that formula to find, that means find, let's draw the bear, to find any x value or values, any x values. That right there, that little block is the most important thing you will need to learn this year. We will go over it in many different circumstances. If you cannot do that, you will likely not get the course. That's kind of the idea. It is a linchpin part of the course.
Okay, what's with defining the rule?
So the rule, I want you to add something else to this one as well. When I say find the rule, next year you may have to find A, H, K in different ways, and I'll show you all that. Finding the rule here, what I mean by that is, can you find A? Because a lot of times that's going to be what's missing, okay? Is finding the rule will mean I need to find the A value. So I'm not going to show you how yet. I'm going to show you later on. Right now, I just want you to write down what would I need to find A? I would need 1 point, xy. And that point cannot be the vertex because I need that as well. If I have both of those things, I can solve for A. That's what I need. Okay? So that is standard form. You're going to see all three forms this year. I will point out to you that the one form you have to perfect using is standard form. Okay? That one, some people like factored form because they're used to it after we've done some factoring and stuff, but it's less effective and useful whenever I have to solve for x's. It becomes problematic. So anyway, general form. Okay, and again, what I'm trying to highlight here is that if I was given a question and the rule I was given was in general form, and I decoded this word problem to identify, what did I miss? H and K. H and K. All right. So what is happening here on this guy is that if I identified, and this is how you're going to use this, if I identify that the question's giving it to me in general form, if I identify from the word problem that I have to find the H, right, because that's part of the answer, then this is the formula I am going to use. Negative b over 2a. The c doesn't matter in that guy because it's a symmetry thing. The c does not matter. The c does not matter. Okay? Yeah.
Um, I know it says positive b in the general formula given, but what if the b is negative? Is it
So
then negative
great.
negative?
So let's just go 2x squared minus 4x plus 6. So what would that mean? H would be equal to positive 4 over 2 times 2. Because I would just negative of the negative. Because that one, and here's the one thing is there's a difference between this guy and this guy. Do you notice? In the rule form, okay, that one has a subtraction in standard form. The general form has addition, meaning I don't need to change anything. Whenever there's like an addition, that's why for the k here, it is what it is, because it's addition. As soon as they input a negative into that rule, into that format, let's just say, then I know that its actual value is the opposite of whatever that would be. Okay. Also in general form, let's just say you're given a question and you identify you want to find the k of that function. It's something along the lines of Tom Brady throws a football. It reaches its peak at 10 seconds. How high did the ball get thrown? Oh, I need to find how high it was. Then I got to find the k. How do I find the k in general form? K is equal to 4ac minus b squared all over 4a. So if you can avoid general form, that's good because it is hard. The formulas are a little bit tougher, uh, but still manageable. Okay. Yep.
Same question. What if the b's are
So,
negative?
so
Is it
that if the b was negative in that one, right? When I square anything, or the better way for me to say it, what is a negative times a negative?
a positive?
So then minus b squared, if it was minus negative 4 squared,
So it would be
it
negative
would
no
be
matter what.
negative. Yeah, so I'd be subtracting. So no matter what, you're right, that's going to be a subtraction. Has to be. Okay. Now, we're used to working in this form already, and you already know the next formula. Negative b plus or minus square root of b squared minus 4ac all divided by 2a. That guy comes in again. So these first two forms I can use to find for x or x's. Okay. So this should give you two answers here, by the way. That's the plus minus there. Okay. Now there are rare circumstances where you can find the rule. Like let's just say they gave you B and they gave you C and they gave you a point, and you can go ahead and find the A. That would be doable, but it's so rare. What I'm going to say is we're never going to try and find it here. Um, at this stage, I would be converting one way or the other. Like I wouldn't. I would never. I wouldn't even just say convert. I would just say if we're trying to find the rule, it's either going to be factored form or vertex form. It's never going to be that form. There's rare circumstances, but not enough for me to like warrant putting it in there. Let's just say I now identify that I have factored form in a question right now. Well, This guy is a little bit different to wrap your brain around. It starts out with a formula, Z1 plus Z2 all divided by 2. So let's just say y, or f of x, is equal to 2x plus 4 x minus 8. Okay? What would that look like? At h is equal to negative 4 plus 8 divided by 2. So that one would be, would you stop moving around? Is equal to 2. So just let's freeze for a second and look at that. When I used this formula, I took the actual values of the zeros. There are subtraction symbols here. So that means its actual value is opposite of what it looks like in said formula. So the first zero is negative 4, the second zero is positive 8. So when I input everything to use this formula, I'm going to take its actual value. So it would be negative 4 plus 8 divided by 2. Right? Now, we're going to add another little addendum to this. We're going to add another little thing here. Start, if you will. You, on these guys here, 4K, you will need H first. It's the only one where it cannot be solved independently. It's the only one in the entire block where I've got to find that guy first. And I had some really good questions last class about this guy because when I go to input it, so we're going to actually try and show you what the K of this guy is here in this scenario. Okay, maybe I'll put an example in. So K, all I'm actually doing is using the rule that I was given and then using the H that I found, right, in place of where the X is. So technically speaking, that formula is me using the rule. It is no different. Stop moving around. It is no different than me solving for a y given a specific x value. These are the same thing. They're the same thing. It's just that I'm finding the mate for the h, which the matching coordinate for h is always k. Those two are always paired together. Okay, so it's kind of redundant. I don't need to put that second one there. I just wanted to kind of explain that. But on this guy, you know how I took the real value of it? Because I'm plugging into the formula again, on this guy, I'm going to say k is equal to 2, 2 plus 4, 2 minus 8. Okay? You can maybe add a little bubble next to this if you want as well. Here's a check that you did it right. If you correctly solve for h, and you're on your way to correctly solving for k, every time without fail, okay, if these two numbers are not the same thing, but one positive and one negative, you screwed up. Your h is wrong. I'll say it again. If inside here, one is not positive, or one's positive and one's negative, and the number itself is the same, then perfect, you solved your h correctly. If you get a 3 and a 4, you screwed up your h. Go back and try again. Okay? So k will be equal to negative 36, negative 72. Okay? So that one is a little bit different because this is like straight up a formula. So Tegan, you were talking about it. This guy here, I'm going to plug in the actual values in here, right? When I'm trying this guy out here. Whereas this one here, I'm plugging in the actual values. And then this guy, I'm really just using the rule. So it's you're going to treat it a little bit differently in a sense. Now, in terms of zeros, intercepts, So step one for zeros, I can solve that really easy. Z1 and Z2. Like, I'm just going to take opposite value from form or from rule, right? So it would be Z1 is equal to -4 and Z2 is equal to +8, right? So that's all that guy is there for zeros part of it. But in order to find x values, so the second part of this guy, you're going to have to convert to find x. So you're either going to convert to this guy or you're going to convert to this guy. And we'll show you how to do that. But he's nice if it's asking for zeros because it's really in the equation. But in terms of solving for other x's on that rule, we're getting out of that form. And that right there is the essence of why it's super important for you to be good with vertex form. Because that way I can use that to solve for my x's. This, again, can't do that, can't pass the course. Okay? Now, last but not least, we're finding the rule of this guy. What is it that I would need in order to find this guy here? Same thing as before. I would need 1 point, and I would need Z1, and I would need Z2. Okay? If I have those three things, then I can solve for the A of that guy. But if I do not have those three things, I'm kind of pooched. Okay? So that is how my brain works, is what I'm going to say to you. I made this a few years ago because it's just what made sense for how my brain operated. Let me back this out. Okay. So I like discretely having everything in one chart for me because when you go to a problem now, you can now identify, hey, I'm in standard form and I need to solve for k. Now I know what to do. Hey, I'm in factored form and I have to solve for k. I now know what I have to do. Okay? You're only going to be using one of these boxes at a time. You won't be doing like all of it at once, but this is what makes sense for my brain. Feel free to rearrange this and put it in a way that makes sense for you, but this is the way I like it. Okay.